Hello guys, welcome to my YouTube channel Data Partnership. So in this video, we will explore how to map, analyze household level water reuse potential using a simple Python code, and we will use sample data to estimate gray water, right? So, so why this is important? We need to know. Nowadays, you can see through newspaper or social media globally there is a water problem is increasing day by day, like sometime few years back, South Africa, in India, Chennai, Bangalore, and other cities, and this is going to happen in potentially in Delhi or means any big cities, because water is a big problem. Fresh water is having problem. Its availability is a problem. Its management is a problem. Of course, government is doing a lot of efforts, and but due to climate change impact and demand is increasing, so it is a very challenging task to manage the water properly. So why? So then we need to understand where one thing is that water is available in the through river, rain, or whatever, and one thing is that how we are using it at household level, right? In the every society, we are having water facilities, water distribution system is there, but sometime in future we need to be ready from here. So this is what I'm going to use a very sample data, that how to analyze and how to calculate the water reuse, right? Means household level water reuse potential. So it will be for water researcher who are doing research, GIS analyst, or who are just curious about sustainable solutions, or industry and technology solution providers, right? So this will help for to everyone. Hands-on tutorial will show you this how this analysis can support smarter water use decisions. And in the coming videos, we'll show how to create a dashboard so that everybody, any industry can use this data for their decision making, and so that their business can be sustainable. So these are the few points here: ensuring water security, minimizing water related risk, promoting sustainable development, supporting economic growth, right? So this will be our this type of our sample data, and this will be an output, right? Means the blue one is gray water, and this green one is uh, rainwater, right? So what is gray water? Gray water is basically the clean wastewater from household activities, including toilet waste. It's the water that has been used once, and but then it is waste. So basically, how it can be used through some technologies. There are a lot of technologies now. A lot of startups are there in India. So that you can use this for irrigation purposes, like for gardening and all, flushing toilets, washing floors, and construction use. So let's start with, so how to do that. So we will use Anaconda for this, and let's go here, Anaconda prompt, and I will activate Conda, activate GISP1. This is my Conda environment. I have created one video for that, and I will share that in the link so that you can use that, right? So uh, so I will just connect this with my folder. Uh, this is my folder, and that's the launch the Jupyter notebook, right? So you can see this is my database which I have created. This is sample data. You can use, you may have much bigger data, and here's a sample that how to use this data, right? I have used household ID, daily water use, gray water percentage, treated water use, house size, roof area, and you can do add a lot of columns. It all depends on your area, but like water availability, timing, or how much, what is the timing of water, how much rainfall is there, and wow, how much the groundwater is using, freshwater, river water, whatever. So a lot of columns you can add here. So based on that, you can do a lot of a lot of calculations. So here I am using those things. So I have launched this. It is there. Oh, no, where is that? I have launched it, right? Where it gone? Yeah, this one. So it's a new. Then you can. So now we will import under SPD import matplotlib dot pyplot as PLT for visualization. Shift enter, run this, and now we'll make a data frame ed dot read CSV since I have CSV file. So, oh sorry, why I'm doing this? Yeah, this is water reuse dot CSV, and yeah. So now if you want to see the data, just write the TF. So this is the data. So here, if you want to see only first few rows, so that we can see all the cells here. So first, now we have to do the calculations, right? We have to do the calculations. What is the calculation? First is we will calculate we have gray water percentage, but how much in the volume we have to calculate that. So DF, that we will create column here, gray water volume, right? In liter. Close it, equal to DF, from which daily water use, this column, using this column, right? This one. Close it, into, from which, into DF, sorry, DF gray water percentage, gray gray water, right? This one, and divided by 100, since it was in the percentage. So now you need to be very careful here, right? You need to close this one. You can do the single one, right? Daily water use into DF, here also it should be like that, right? So it's a run. You can run it. Then now you can see the DF, right? Gray water percentage. So it means it is giving problem here. Gray water. Okay, W is capital here. Yeah. So now you can see. So we have one more column called gray water volume. So similarly, what you can do is you can write only dot head, right? Yeah. So similarly, what is a reuse potential daily, right? How much we have potential to reuse the water. So what we can do is reuse potential daily in liter, right? So how much it should be? I have to close this one. Be very careful, right? And gray water volume. So which we have calculated here. We just copy from here, and gray water volume into How we can into treated for reuse means we are how much we can reuse means how much volume is available and how much we are treating it. So after so that how much percentage of this gray water we are treating it, then it will gives us the reuse potential daily, right? It's a simple thing. DF and this one. I'm just copying from here. Control C. Yeah, I just want to avoid the spellings mistakes and all. And divided by 100. So it's incomplete. Okay, you have to close it. Yeah. Yeah. Same thing. DF. Yeah. So now you can see DF. So we have this is our reuse potential daily. So out of daily water, how much we are using? 500. And how much we can reuse? 240 liter. So you can see how much water we can save here, right? So this is the beauty of this analysis. Ah, so, so similarly, now based on this, we can calculate the monthly and annual. So how we can do? We can say the monthly calculations. Yeah. So DF, what we are going to do is the reuse potential. So how we can do is reuse potential which we have. I will copy this one whole thing, right? We need daily, monthly, right? And what should be there? Equal to DF reuse potential daily, right? So this one, reuse potential daily, we'll just copy this one into, if monthly means 30 days. Yeah, so you can see DF. So you have reuse potential monthly in this one. With the sample data, you can realize that how much it could be, right? So how much water we can save if we do this kind of calculations. So suppose right now I will just copy and paste here. This is the yearly annual annual calculations. So similarly, one at the in place of you can write annual, right, and reuse potential daily into 365. You can see now we have here one more column reuse potential annually. Means you can see if you have a dashboard, then you can see all. I will definitely create in future. So, but right now we have to start from here. So you can see this is and how much cost you can save. So now what we can do is since these are the these calculation is in liter. So best thing is that we have to calculate this in cubic meter, right? So now we have to do some calculations here. So it's the cost saving, right? So in the cost saving, what you can see, water, we will define something. Water cost per meter cube, right? Equal to, you can say 25. Per meter cube is 25. So, so how much? So there we need to create a formula, right? So DF is this DF annual annual savings, right? In rupees. Whatever. These calculation is are in rupees. Equal to DF. What should be the annual reuse meter cube, right? So annual reuse we will do is No, first what we'll do is, before this, I forgot one thing, that we need to convert this liter into uh, meter cube. So how we can do is df, that annual reuse in meter cube, right, equal to df dash reuse this one. Just copy this one here, copy, paste, divided by 1000. So you can see this is uh, okay. So what happened is, sorry, I'm always doing the same mistakes, right? So you can see we have uh, this calculation is in meter cube, right? You can use liter also. I'm just telling because sometimes cubic meter is generally the preferred language in technical. That's why, right? So if we cost saving means water cost per meter cube is 25. So how much we can save? So the total saving, how much it will be, is that is df dot this one, df this one, right, into water cost per, this will be our formula, right? So this will be our formula. So now what will be the totals? Then we will see the how much the totals will be. Totals means is the total saving equal to df annual saving, this one, df annual saving dot total sum, how much it should be. So if you run this, now you can see df, right? So you can see total, this one is annual saving, how much saving at a per household annually we can save this, right? And total saving is like this. So if you want to see the total total savings, you can say this one, this much amount, 22,971. I have taken only the sample, I think 10, 15, 10, 15 to 12 households. So you can see if it is for lakh household, or or something, millions household, so how can money we can save so that we can use that in other purposes, right? So this one is the, now we can like this, we can write this one in such a way that, so that you will have print, like you can print it, print df, like you know uh, household id, copy, paste. Just this is more, this is another way, reuse daily, reuse potential daily, right? And you can put this one also, reuse monthly, right, comma, you can see annually, uh, right, and you can say annual savings also, or like this, comma, annual savings, right? like this. Okay, I will just put this one and this one, right? And this one, right? It will be like this. So you can see in this form. So everything and this, right? Or total saving I have already print. And if you want to see in this in graph, then you can create a bar chart for this. How to plt dot figure and fig size equal to 8 5, right? 5, and then plt dot bar, you can see df, and df means this household id. You can see household id, comma, with the annual savings, right? How much we are saving, annual savings, df, this one is, sorry, is annual saving, and color is something you can write T. Yeah. So close, right? And then run here. So we can check the problem here only. So okay. So up to now you can see in this way. You can see these are the household and this is uh, the value amount. So we can write title plt dot title, how much what it should be. You can write that annual water reuse savings per households, right? Not in close, right? You can add means whatever, like you can add this one plt dot. Why I'm doing in all the my videos like this is so that you will have a habit to do this again and again, right? Otherwise you will forget. Yes. Households and plt dot label is savings in INR, whatever, right? And see syntax error. Okay, this one. So this we can do in such a way. So this is what I wanted to show you, basically based on the a very simple data. If you have, then in next video, how I will show you, what I will show you is that if you want to calculate like cost saving or impact, what is the impact of this thing means how what will be the impact of rainfall, like how much we can save, or what will be the impact of these things. So I will definitely would like to do this because this is an important part of this analysis, right? So I will definitely basically it is the I think it is means how much rainwater reuse we can, and what is the potential of rainwater So I will do in this in my next video, and you can do by yourself also. I have already this. You can create your own data, and based on that, you can try this. And in next video, definitely I will do next means after this what will happen means I will extended version of this analysis, right? Thank you. Please subscribe my channel and share it and like my videos so that I will do more for you. Thank you.